Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we are looking at law of sines. This is something that might be useful for the ACT. It's definitely a pre-calc topic. It's an idea in a way of how to solve or complete triangles that are not right triangles. So when do you use law of sines? This is used whenever you have something, or it's whenever you have a triangle that is not a right triangle. Right triangles, we can just use our basic right triangle trig, sine, opposite over hypotenuse, etc. That does not work though when it's not right. So law of sines fixes that issue for us. Law of sines allows us to make these ratios of the sides and the angles together. Here is law of sines. It says sine of A over A is equal to, notice the ratios, notice the fractions, sine of B over B, and sine of C over C. Realize you don't need to use all three of those fractions. You may only use two of them when you're actually solving, but it does just say that every angle inside are proportional whenever we take sine of those angles. Realize this form can be flipped as well, just depending on what you're solving for. It might be easier if you use a specific type. And then the other thing I want you to notice is the capital letters versus the lowercase. We generally use capital letters for angles and lowercase for sides. So if I were to just draw some random triangle, notice it's not a right triangle. It kind of looks equilateral, okay? But it's not a right triangle. We know that if we have different angles, maybe angle A, B, and C, the sides that we are talking about then are the ones that are directly across. So if this is angle A, side A is on the opposite side between the other two angles. That means side B would be here and side C would be on its far side. So knowing this, then we can go ahead and solve or complete these different triangles. All that means is find all the missing sides and angles. Well, in this first two cases here, we're going to be given two angles, which makes solving for the angles pretty easy. One thing I always like to do, though, is just draw a triangle. Your triangle doesn't have to be perfect, but let's just go ahead and draw some triangle in there. They tell us that we have an angle of 40, an angle of 60, and we also know that side A go across from it is 4 units. Well, one thing we need to know is angle C. Well, if we know that the inside of a triangle adds to 180, we could simply subtract these other two parts and end up getting a value of 80 for angle C. Now what we need to do is find side B and side C. Let's start with side B. Well, in order to utilize law of sines, you need to use a side and an angle that are together, right? For example, side A and angle A, we can use those because we know both of them. We're solving for a side, so I'm going to put the sides on top. So the side A over sine of angle A, where angle A is 40 degrees. Well, let's solve for side B. So side B there is on top then, over sine of its respective angle. Well, from here, all we need to do is get the B by itself. That means I'm going to multiply sine of 60 to the other side. And once you do that, all you need to do is just type that in your calculator. That's just calculator work at that step. Make sure we're in degrees when we do our calculation, and you should get roughly 5.389. Now we have another side. Well, we can use that same sort of setup then to find the remaining sides. That's the reason law of sines is kind of nice, is because it's always the same setup and you can just keep repeating it to find the different parts. Notice, though, I need to use sine of 80 instead because that is the angle C when we're solving for the side C. I'm still going to multiply that value up. And again, I'm going to type it in my calculator and end up getting 6.128, something around there. That is our idea of law of sines. You might be given a different case, angle side angle instead of angle angle side. That's just the order of the different information. But we're given an angle that is 35. There's angle A. We're given angle B, which is 15. But notice now the side that we're given is side C. It's in between the two angles, right? That's the angle side angle idea. But if we know two angles, the easiest thing to do is still to figure out the missing angles, to subtract both those values from 180, find a value of 130. And now this problem is just like the one we just had. We can use the side and the angle that we know. In this case, that would be the angle C and side C. We're still solving for the sides, so I'm going to put those on top. Maybe we want to find A first, and we use its respective angle. We solve this equation, and when you do so, you end up getting that A is roughly 3.743. And then you just continue to repeat the process for whatever sides you need to find. Multiply that value up again. I'm just going to move it over like that, save ourselves some extra work. Sine of, that one was sine of 15. So now that gives us B. Type it into your calculator, find your value. This tells us B is equal to 1.689. But, okay, what if we are given something else? Maybe we're not even given two angles and a side. Maybe we're given two sides and one angle. Well, this process is still possible as long as you have the angle and the side that are together. Okay, for example, this is side X angle X and side X. Maybe I labeled this one as Y, angle Y and side Y. Notice we have those correlating pieces. I am missing another angle and another side, but that's fine as long as I have enough information for both of them, then we can actually solve. So now I want an angle, so maybe I put the angle on top of the fraction this time. So sine X over its side. That means I would need sine of the other angle over side Y, which is 22. And the solving starts the same. We can still start by multiplying the value over. So 12 times sine of 42 over 22. You might type that into your calculator, but realize the next thing we have to do here is get X by itself. Well, if we have sine of X, remember to undo an operation, you're taking an inverse. So I'm inverting sine to move it to the other side. And now we're typing this entire part into our calculator. When we type it in, we end up getting a value of about 21.406. Now we've solved for the missing angle, and then from there, the process would be the same as above. Let's look at something a little bit more challenging, though. Let's look at example 3 here. It says that to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance of 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47, and the second results in an angle of 35. If the transit is 2 meters high, what is the height of the mountain? Notice we're given two diagrams here. They're diagramming the same thing. One with the mountain and the person in the diagram, and the other one specifically just looking at the different parts, and maybe the parts that we need to find. But what I think is useful here is breaking it down to really only look at one of these triangles. Well, what we know is we have a triangle that looks like this. And I have to start with this triangle because this is the only triangle that I know one of the sides to. I know a singular angle in it, but we could find other angles. Well, I know that we have this exterior angle of 47. Well, remember, two things that form a line, those must add to 180. So we could find the angle on the inside by just doing 180 minus 47. When you do that subtraction, you end up getting 133. Okay, so that helps us with this triangle then. We have two angles now. But I don't have the angle that correlates with this 900 yet. So now let's do our subtraction of 35 and 133 to find that the missing angle that we need here is 12 degrees. Well, that's good. That is very beneficial to us. Well, we need to figure out if we want to utilize the 35 or the 133, and you would be fine to utilize both. What I'm thinking about, though, is our next step after this. Our next step is going to be looking at this big triangle, where this big triangle we know is still 35 on the inside. Now it's going to be a right angle because we're just measuring a height of something, right? Height is directly up and down. And we would need this hypotenuse value then. Well, that value of C is on both of these. So we could utilize this smaller triangle to then use it for the big one. So let's use our law of sines then to find side C. In order to find side C, that means I would be using the angle of 133. We take the values where you have the sides on top over sine of their respective angles. When we do that, all we're doing is solving right here. So I could multiply the sine of 133 up, type it in my calculator, and find what we get. In our calculator, that ends up coming out to 3,165.855. That's a bad 5. So we end up finding this side then. And again, the reason we found that side is because we could look at this bigger triangle where that side is the exact same. Well, now we still have the angle of 35. We have this side. We could find the missing angle if we needed to, but I don't think we need to in order to find the missing height of this part. So now we can look at this other triangle and we can use law of sines again, where B is now over sine of 35. And that's equal to the value we just found over sine of 90. Well, multiply the values up and let's see what we get. When we multiply sine of 35 to the other side, what I end up getting in my calculator is, one second, let me finish writing. What I end up getting is 1,815.86. You could use more decimals than that. I rounded that. You might call it 859 instead if you want 3 decimals. And okay, you might be thinking we have the height of the mountain, but that's not quite correct because there was a person who was observing this. That person was standing up on the ground looking through binoculars or something to find the angle of elevation. So that means that wherever he was measuring it from was his eyes and not the ground. So there is still a minimal distance that we need to include. Well, if we look at our diagram again, we found this value of B is the 1850. So in order to get the extra height, the entire height of the mountain, you have to include where they were measuring it from, which was roughly 2 meters above the ground, where their eyes were. So now to find the height, we can do that simple addition. Add the 2 with it, and we find that the height of the mountain is 1817 meters instead. There is our final answer. Thanks for watching. That is law of sines. You can now see kind of how to break down some word problems. Thanks for watching. I'll see you guys next time.